Let me just cover some of the boards very quickly. So there are basically 4 board types available. One called a CDLSU, the TMC board, and 2 minor boards which allow you to get a Focuser up and running very quickly. So this is the CDLSU board. It actually stood for CL42T, D for DRB8825, L for L298N, S I've actually dropped, and U for ULN 2003. So down here in this place here, what you see is where the DRB8825 chip will sit, and you would put headers in here so you can remove the chip if needed. But there are also 2 connectors here, J11 and J14, which allow you to connect an L298 board, a ULN 2003 and a CL42T board to these connectors if you don't want to implement the DRB8825. Obviously you can't run all these things at once, it's only one of them. But this board gives you the flexibility of supporting all the various Focuser types on one board. So if you found that you didn't like, for example, you found that you implemented it with a 28 BGY motor and a ULN 2003, found out that didn't have enough torque, what you could do is you could then go to a DRB8825 and not throw any of this away. So that's pretty cool. This is the TMC board, and it supports the TMC2209 and 2225 Bigtree driver chips. Notice there's no support here. That support for other board type, other driver types doesn't exist. So this board only supports the TMC devices. I don't really see the need to have it, but that's what it is. This is the what we call the TZT. And TZT is this particular board here. Comes with an S3 processor and it's N16R8. It does come in other variations like M8, R8, etc. But this is the board N16R8, which is the recommended board. And it shows you here how various things can be wired up. This is a example of a DRB8825, and you notice that supported on all TZT boards are home position switch, power on off of course, OLED display, the DRB8825, stepper motor and a temperature probe. So those are all supported on every single TZT board. And there are different variations depending upon whether you wanted ULN 2003 and so on. And the last board is this thing called a terminal adapter board. And it's just a basic socket with a whole lot of screw pins on. And here we have 12 volt supply, of course, for powering the 12 volts to the stepper. We have the same OLED, same on off, same home position switch, same temperature probe, same display. So you can implement all of these things, basically temperature probe, display, driver chip, home position switch, on any board that you select. So those are the 4 different board types. The S3 chip goes here, the DRB8825 chip goes here, and so on. Now, the great thing about this board is that it supports 4 different driver boards. So you've got the DRB8825, so if you're using that, you'd plug in the header pins and then you would insert the DRB8825 chip into those header pins. And we label these DIR DN, VMOT, EN, which match the pins on the driver chip. Now if you don't want to use this board for the GRB8825 but you prefer to use it for the ULN 2003, then no problem. Don't put the GRB8825 chip in here. Just connect up the ULN 2003 board, IN1 to IN4, power to ground. That goes straight to the driver board, and here you select 12 volts. So if we were to look, this is how we connect it all up in terms of the actual wiring. So we've got the J11 connector for IN1 to IN4, power and ground. We've got power selected as 12 volts, and you can see here that it wires through the various connectors on the driver board. The output of the driver board goes into just the connection to which we can connect the stepper motor. So that's quite straightforward, and very similar of course for the ULN 2003. If we wanted to connect up here the DRB8825, of course we take J13, which is the output, and we wire the stepper motor to it. And last but not least, the ULN 2003. Again, we use the IN1 to IN4, the power and ground, to go to the driver board, and we take the output of the driver board and feed it into a stepper motor. Now, in all of these, I haven't discussed the option of CL42T driver board. This CL42T is a zero loss driver solution, so there is no way it's ever going to miss steps through slippage or anything else. The stepper motor is a special stepper motor with a built-in decoder, so if you really wanted a sort of really good focuser system, you would choose the CL42T. It's available as a kit set with the driver board, the stepper motor, and the power supply. It requires a separate power supply, can't drive it from the board. But again, it gives a very effective high-end focuser solution. The TMC boards, it only supports the TMC 2209, 225 Bigtree stepper drivers. They fit in this position here for IC2. The diag pin actually goes through and connects to the board, and that has to be wired if you want to use stall guard. And stall guard is a technique whereby when the stepper motor is moving a bit, and when the stepper motor is moving and it hits a solid object, i.e. it's gone as far as it can go in and can't go any further, there's an increase in current draw because of that stoppage, and that triggers the diag pin, and that diag pin is wired to the home switch position, which detects the fact that it's at the home position. So that can be done in both software and hardware, and takes a bit of setting up. So again, we have the typical header boards for ground. We've got typical boards for 5 volt, 3 volt header connections. We've got OLED, joystick, etc. And we've got a connection to the stepper motor. So all of that's quite similar. There's one small change on the TMC boards, and that is MS1 IN4 has been swapped pins to resolve a tracking issue on the PC board. I didn't want to use a VIA to swap layers, so it was far easier just to turn around and swap the pins. So there is that single change. terms of the diagram, look, it looks virtually identical to the previous CDLSU PC board, except it's got this extra pin, jumper pin down here, J21, for selecting the source of the home position switch. So you can use a standard home position switch, or you can set it to diag, and the diag or stall guard is only available on a TMC2209, and if you find that's too difficult to actually get running, then all you do is you pull the TMC2209 chip out and put a 2225 in as a replacement. And if you want the home position switch, then what you do is you wire up this J21 header using a motherboard shunt jumper between COM and TMC2225. This is the TZT board, and again, this chip down here is a ESP32S3 TADPT C1 N16R8, so it's got the 16 megabytes of flash. Here is a little connector for connecting an external Wi-Fi connector, Wi-Fi aerial, and you can use that to extend the range. Has a reset switch. Here is the USB connector. It's a C-type, and there's only one of them. 5-volt power goes in here. We power the stepper motors separately, and you get a number of header connectors on here, of which we can connect things. And here we see the actual diagram of wiring. In this particular case, these boards will handle a 12-volt external supply, so I've done that and used a single 12-volt supply, and the stepper motor requires 12 volts, so I get 12 volts from the V in, which is 12 volts from here, and then wire it through an on-off switch into the power for the DOB8825 driver chip. Don't be confused by this wire here, the blue wire, because it's not connected in this particular circuit, so you don't need to put that blue wire in. So we've got the display over here, we've got the home position switch wired in, and I've soldered a 100 nanofarad small capacitor across the COM and the normally open pin, just to try and get rid of any noise that might be induced in the signal pair that's running between the switch and the board. We got a temperature probe, and we've got a wiring of the stepper motor to this particular board as well. The step mode is selected on the actual board itself. You can't set, for the DOB8825, you can't set this by software, so that's why it's called fixed step mode. For the ULN 2003 L298, those support both step mode 1 and half steps in software, so fixed step mode doesn't apply, and we would set it to -1 in the config when we get round to doing that. So that's the development board. There's a terminal adapter board, which is just this board with a couple of header terminals, screw terminals for connections, and some header pins to put the chip inserted in here. And this is not to scale, by the way. And so you can wire the 44 pin N16R8 ESP32S3 TADPT C1 chip onto this board. Can't use any other chip, must use this chip, and it supports the DOB8825 solution, an L298N, and a ULN 2003. And the options for the terminal adapter board is the three most important ones: first being home position switch, temperature probe and fast ping display. So this is what the diagram looks like. You've got a USB connector here, type C, which should plug into your computer. There are two available, but this one I found to work reliably, and you can see the chip mounted in here now. We've got various wires which run between the header screw connectors and the actual devices itself. Now powering this from a 5-volt supply, because you can't feed 12 volts into this chip. There's no other components, it's just this chip only. So you don't have a drop down regulator to convert from 12 volts to 3 volts, or what you've got is you've got a chip which will take 5 volts in and connect and convert it to, and this is this regulator here, which converts from the 5 volts into 3.3 volts for the chip. So we're using a separate 12 volt power supply to drive the power for the stepper motor, and in this particular example I'm using a ULN 2003. So I've got the temperature switch wiring the same, got the display wiring the same, the home position switch the same. Obviously ground means ground, home position switch means home position switch. So these two arrows here indicate that it goes to the home position switch. And I'm using a 12 volt 28 BYJ48 stepper motor, and the reason for that is because it's got significantly more torque than the 5 volt motor, and if you try to use a 5 volt motor it's not going to go very far, and for most applications, except for something like a Celestron SCT etc., which doesn't require huge grunt to change focus, in most cases it's far better to use the 12 volt stepper motor and not run into trouble. This is what the wiring looks for a LT980N, and you can see very similar, all the wiring to the various components, separate 12 volt supply on and off switch for 12 volts. We've changed this from a ULN 2003 to a LT980N, and the LT980N can actually drive a NEMA stepper motor, so that's why that option is here. You don't have to fiddle around with any currents or anything, you just plug this thing in and away it goes. But unfortunately, of course, you can't use any can't really use micro stepping on the stepper motor. You've only got full and half stepping. So next up we'll talk about the Arduino IDE and how to configure that and get it running for this project.